Today we will look at finite geometric sequences and series. Okay, so when we refer to a geometric sequence, we're referring to if the ratios of consecutive terms are the same. So for example, if I have a sequence A1 all the way to AN, it is geometric only if I take the second term divided by the first, which should equal the third divided by the second, which should equal the fourth divided by the third, to get some common ratio r, and r cannot be 0. The number r is our common ratio of the geometric sequence. So if we look at some examples here, so notice we have this first geometric sequence 1, 5, 25, 125, 625. Well, if I take 625 divided by 125, we do get 5. 125 divided by 25 is 5. 25 divided by 5 is 5. 5 divided by 1 is 5. So the common ratio is 5. If we look at the next one, 4, 8, 16, it's going by multiples of 4. Well, the ratio is 4. We know 64 divided by 30, multiple of 2. 64 divided by 32 is 2. 32 divided by 16 is 2. 16 divided by 8 is 2. 8 divided by 4 is 2. So therefore the common ratio is 2. If we look at the next one, it is a alternating sign sequence, but we know negative 12 divided by 6 is positive 2. 24 divided by negative 12 is negative 2. Negative 48 divided by 24 is negative 2, and 96 divided by negative 48 is negative 2. So the common ratio for that one is negative 2. And then if we look at the last one, we have 9, negative 3, 1, negative 1/3, and 1/9. Well, we know negative 3 over 9 is negative 1 over 3. 1 divided by negative 3 is negative 1/3. Negative 1/3 divided by 1 is negative 1/3. 1/9 divided by negative 1/3 is negative 1/3. Therefore, our ratio is negative 1/3. So you might encounter a couple examples where it'll say determine if the sequence is geometric. If we look at our next type of problem, we're going to write the first 6 terms of the geometric sequence, with the first term being 6 and the common ratio being 1/3. Okay, so if the first one is 6 and the ratio is 1/3, to get A2 we would do 6 times 1/3, right? Because that's our common ratio. We would have 2. The third term, 2 times 1/3 is 2/3. The fourth term, let's see, 2/3 times 1/3 would be 2 over 9. The fifth term, 2 over 9 times 1/3 is 2 over 27. And then our sixth term, 2/27 times 1/3 is 2 over 81. Take a minute or two and try this example you try. When we start talking about the nth term of a geometric sequence, the formula that we need to be able to recognize and know is this a sub n equals a1 times r to the n minus 1 power, where r is the common ratio of the consecutive terms of the sequence. So every geometric sequence can be written in this form. So notice for a1, we just have a1. a2 is a1 times r to the 2 minus 1 power, or r to the first. For a3, a1 times r squared, or a1 times r to the 3 minus 1 power. a4, a1 r cubed, or a1 r to the 4 minus 1 power, and it continues on until our nth term. So if we look at our next problem, it says we're going to find the 6th term of the geometric sequence given the first term and the common ratio. So the first thing that we will actually do is we will use our geometric ratio formula, which is follows. And then we will plug in our values for A1, So a sub n equals 8 times 1 over 2 to the n minus 1 power. And then the next step is just to plug 6 in for n. So we find a sub 6 is equal to the first term times our common ratio to the 6 minus 1 power. 6 minus 1 is 5. 1/2 to the 5th power is 1 over 32. So in this case, we get 1 over 4. I would like you to take a minute and try the example you tried. Hopefully you found for your example you try answer 3,645. If we look at another example, the first thing we'll have to do when we're given a sequence and we want to find the rule for the nth term, the first thing that we can do is we can first of all identify a1. We know it to be 2/5. And our common ratio, if we take 2 divided by 2/5, remember that's the same thing as saying 2 over 1 times 5 over 2. And in this case, we do get a common ratio of 5. And that is illustrated if we took 10 divided by 2, we would get 5. 50 divided by 10, we would get 5. 250 divided by 50, we would get 5. Okay. So then our next step is to just write the rule for the nth term. A sub n equals our first term times the common ratio to the n minus 1 power. Or in this case, a sub n equals 2/5 times 5 to the n minus 1 power. Take a minute or two and try the example you tried. Hopefully you found a sub n equals 6 times -2 to the n minus 1 power. Now we're ready to talk about sums of a finite sequence. Now, if we had a textbook, it's the one with the pepper on it. The proof is on page 991. But the sum of a finite geometric sequence as follows, with a common ratio r is not equal to 1, is given by this formula. So if I wanted to take the sum of all values of a1 times r to the n minus 1 power, where I is 1 and n is the last term, we can do our a first term times 1 minus the ratio to the nth power divided by 1 minus r. So if we look at our next type of problem, this time we're looking at something in summation notation already. So the first thing we'll do is we'll find that first term. So our first term is 6 times 2 to the first power, which in this case is 12. We'll need to identify our common ratio. That would be our next step. So our common ratio, if we look in the summation notation, there is a clue. Whatever is raised to your power is your ratio. So in this case, r is 2, and we have 10 terms, and we get that from what's at the top of our summation notation. The next thing we'll do is we'll actually find the sum. So the sum of the 10 terms is equal to our first term times 1 minus our common ratio to the nth power divided by 1 minus that common ratio. And then we can go straight to a calculator. If you aren't comfortable with that, you can simplify as we go. So 1 minus 2 to the 10th is negative 1,023, and over 1 minus 2, which is negative 1. So we would just take 12 times 1,023, because a negative divided by a negative is a positive, and get 12,276. So remember, in the very first part of the unit, we would write out our sums and then add them together. That way would also work. Now I would like you to take a minute or two and try this example you tried. And hopefully for this one, you found something around 19,680. Okay, so we're just going to practice doing more of the same. So notice we have something in summation notation. We know it will be a geometric because we have a1 times r to the nth power. Okay, so actually it's not a1. First thing we'll do is we'll find our first term. So a1 equals 2 times negative 3 to the first power. In this case, this would be negative 6. We know our ratio is -3 and we have 6 terms. So if we wanted to use our sum formula for the 6 terms, we would have, -6 times 1 minus a -3 to the 6th power divided by 1 minus -3. Okay, so the sum of the 6 terms is -6 times -728 over 4, which should give you 1092. Now, we can do this problem like we did before with summation notation. So we could have started at the first term and continued until we got to the 6th. And let's see if we get the same solution. Oh, I started writing in 4s instead of 3s. Whoopsies. So as you can see, when we simplify and add, we do get the same answer. So unless the problem explicitly says use the sum formula, you can work this type of problem out in this manner. I want you to take a second and try the example you try. It's time to practice. The end.